Good morning everyone. I am BHOWMIK, chemistry teacher of our ICSE school. Today I am going to discuss the first chapter of class 10 chemistry, periodic table, periodic properties and the variation of these properties. Today we have first class, so we have to discuss the first 2 to 3 basic rules. So get ready with your copy and pen. Okay. This chapter started with the concept of Döbereiner's triad rule. Try to understand. First, we have to understand the concept of Döbereiner's triad rule and Newlands Octaves rule. Okay. Whenever we will try to discuss the Döbereiner's triad rule, we have to memorize a term, atomic weight. And for Newlands octet rules, atomic masses. Okay, so first try to understand. In case of Döbereiner, clear your concept first. In case of Döbereiner's triad rule, we have considered the term atomic weight. Okay, now what is Döbereiner's triad rule? The word is there, triad. So this law related with the 3 elements. That is why it is called Döbereiner's triad rule. Triad means 3. It is called Newlands octet rule. So from the name it is very clear that 8 elements are there. Octets rule. Okay. So what is the Döbereiner triad rule? If you consider the 3 elements, because triad rule, so 3 elements A, B, C. Keeping in your mind Döbereiner's triad rules related to atomic weight and Newlands octet rule related to atomic masses. So atomic weight of the suppose element capital A is small a, B is small b and C is small c. So what is the rule? The atomic weight of the middle one, suppose B, atomic weight of middle one is B. So atomic weight of middle one is the algebraic sum divided by 2. That is the average of the rest of the 2 elements. So what is the atomic weight of the middle elements? That is B. If you take B, so atomic weight of the middle element is the average of the rest of the 2 elements. Okay. If you want to give example, suppose calcium, strontium and barium. So from this example ABC, it is clear that the atomic weight of B is equal to algebraic sum divided by 2, that is the average of the rest of the 2 elements. So here what is the atomic weight of the strontium? Atomic weight of the strontium is the average of the rest of the 2 elements. Okay, the atomic weight of calcium is 40, it is 37, 137. So what is the atomic weight of strontium? 40 plus 137, 40 plus 137 divided by 2, it is nearly equal 88. Okay, so this is the Döbereiner's triad rule. Keeping in your mind it is related to atomic weight. Atomic weight of the middle elements is the average of the rest of the 2 elements. Memorize the example calcium, strontium, barium. Okay, you can memorize the other example also, chlorine, bromine, iodine. Here also the atomic weight of the bromine, obviously the average of the chlorine and iodine. Okay, this is the Döbereiner's triad rule. Okay, done. Now Newlands octet rules. What is the Newlands octet rules? Since octet rule, so this is related to 8 elements. Try to understand this is related to atomic masses. So if we arrange the 8 elements A, B, C, D and so on. So it is first element, second element, third element, fourth element up to 8 element. Okay. So if we arrange the element in according to their increasing order of atomic masses, because Newlands triad law related to atomic masses, so we have to first arrange the element in increasing order of their atomic masses. So after arranging the elements in increasing order of their atomic masses, the properties of the 8th element is resemble with the properties of the first element. So that is why it is called the octet rules related to 8th element. the characteristics or the properties of the eighth element is related to the first element. Okay, so tell me what is the property of the second element. Obviously, if you consider second element, so obviously this property matched with the ninth element. If you consider the first element, so see, first, second, third, fourth, fifth, sixth, seven, eight. So with respect to this element, it is the eighth element. So the properties of the second element is resemble with the ninth element. Understand all of you? So always if you consider the any element with respect to that element, eighth element show the same, more or less same properties of that element. Okay, but we have the limitation of this law. Up to atomic number 20, that is up to calcium, we can apply this law. Okay, after calcium, generally elements cannot properly follow this law. Okay, so done. This is the Newlands octaves law. Now next, okay, Mendeleev first the scientist who arranged the elements in the proper periodic form. Try to understand, Mendeleev the first scientist who arranged the element in first tabular form. He first arranged the element. Okay, now arrange the table in this way. This is called column. Up to down, as you move up to down, this is called column. Okay, now look at the board again. Mendeleev first arrange the element in tabular form. Look at the board. Okay, if you observe the table properly, there are two boxes. One box is up and down. See this one, first, this is second, this is third, it is fourth, and last one is fifth. Okay, and again if you consider this one, left to right, so it is first, left to right, all these box, it is second, it is third. Okay, so downwards, up to down, it is known as column or groups. So it is first column or first group, it is second column or second group. So up and down, this up and down is known as column or group. And as you move left to right, that is horizontal. As we move left to right, this is called the rows. Okay, so this is called row, and it is called up to down, it is known as column. Okay, first this is the primary concept of the Mendeleev periodic table. So try to understand, it is Döbereiner Triads law, so related to 3, Octaves law, and it is Mendeleev periodic law. So first we have to understand what is periodic table. Mendeleev first the scientist who arranged the elements in some groups, that is column, and some horizontal row. So it is called vertical column and it is called horizontal row. This is the primary concept. Now what is the law? That is, what is the Mendeleev periodic law? Okay, Mendeleev periodic law also related to these atomic masses. Atomic masses. So Döbereiner triad law related to atomic weight. This is atomic masses. Mendeleev also atomic masses. So since these two are related to atomic masses, so again think about this law. What is Newlands octet law? As we start from a first element, so it show the same characteristics with the eighth element. Okay, but Mendeleev don't consider the position. Means Newland consider the position 8. First element resemble with 8th element. Okay, but Mendeleev don't consider any position. First element resemble with maybe 6th element, 7th element, and like that. So Mendeleev don't consider any position particularly. Newland consider 8th element. But Mendeleev don't choose a particular position. 8th position, there is a no position in Mendeleev law. So what is the Mendeleev law? The property of the element, look at the board, A, B, C, D. So it is called, according to Mendeleev periodic table, it is called row. And as you move downward, suppose A dash, A double dash, like that. As you move downward, it is called column. So previously that I told, Mendeleev do not consider any position like Newland. Newland consider 8, a particular number. Characteristics of the first element, again will arise in 8th position. But Mendeleev periodic law is the properties of the element compare with the Newland. Property of the element will reappear, or property of the element are the periodic function of their atomic masses. Try to understand. Here the properties of the element reappear in 8, but Mendeleev law is property of the element is the periodic function of their atomic masses. Try to understand this word is important, periodic function. So suppose this is a period A B C D. Suppose it is A, B dash, C dash, D dash. It is A double dash, B double dash, C double dash, D double dash. So suppose these three are the periods. So Mendeleev periodic law is the properties of the element are the periodic function of their atomic masses. So if you arrange, suppose its atomic mass is 1, 2, 3, 4. Suppose its atomic masses is 10, 11, 12, 13. It's 20, 21, 22, 23. Suppose. So its property of the element is the function of their atomic masses. So if we arrange the element in the order of the atomic masses, atomic mass 1, 2, 3, 4. So if we arrange the element in the atomic masses in a period, whole period contain more or less same property. Again, properties of the element is the periodic function. Periodic, this is period. So periodic function of the atomic masses. If we arrange the element with respect to their atomic masses in a complete period, their property more or less same. But here the property of the elements will reappear in 8. There is no position here. Whole period. If we arrange the element in increasing order of their atomic masses, whole period more or less have the same property. This period same property more or less, not exactly this period also. So this is called Mendeleev's periodic law. Okay. Now here we have a term is called periodicity. So what is periodicity? So keeping in your mind there is a particular position of the each concept. If you understand what is the periodicity at the first, so you cannot resemble with this concept with the Mendeleev periodic table. You have to understand the concept of periodicity after the Mendeleev periodic law. Again, if you consider the Mendeleev periodic law, their properties will reappear not at particular 8. Their property is a complete periodic function. So what is periodicity? What is periodicity? Periodicity is related to same Mendeleev periodic law. Their property will reappear in the same group. So their property reappears in a particular group. It is called the periodicity. Okay. I will discuss in next class about the radius, but try to understand as you move downwards, their radius slowly decreases. Why? That will I discuss later in the next class. So as you move left to right, what is the Mendeleev again? What is the Mendeleev periodic law? Their properties are the periodic function of their atomic masses. This is very important and good word. As we arrange the element with respect to their atomic masses, then their property of the particular element are the periodic function of their atomic masses. What do you mean by the periodic function? As I told, if you consider a particular group, their property more or less same, not same. More or less same means if you consider the periodic property, which property? This radius or size. Size is also one property. We have so many properties in our chapter. Size, ionization energy, electron affinity, electronegativity, so on. First, if we consider the size, if you consider suppose it is A, it is B, it is C, so A, B, C, D. So according to Mendeleev periodic law, if you arrange the element in the increasing order of their atomic masses, suppose it atomic masses 1, 2, 3, 4 as I told here, okay, so there see radius slowly decreases. So again give the focus, Mendeleev periodic law, property of our elements are the periodic function. We arrange this is called period. We arrange the element in periodic function of their atomic masses. So when we arrange the elements, their radius slowly decreases. It is called periodicity. So what is periodicity? As we move left to right, so along the period, their property reappear. Reappear means like Newland, reappear at 8. So their property reappears or decreases, sometime increases. It is called periodicity. So in the word periodicity, there is a word periodic. So related to period. Okay. So elements, their property increases sometimes decreases, or sometimes reappears. It is called periodicity. Okay. So Mendeleev periodic table is the modern law. Later, Mendeleev periodic table is the periodic law related to this table, and later the scientist Moseley give the modern periodic law. Now my question is, why this law required, that is modern periodic law required, that is what is the drawback of the Mendeleev periodic law? If we have any drawback in the Newland, I already told, we cannot apply this law after 20, that is after calcium. So what is the drawback or flaws of Mendeleev periodic law? That's why we need another modern law, that is Moseley's law. So what is the drawback of Mendeleev periodic law? So try to understand. Okay, look at the board. Mendeleev arranged the element with respect to their atomic masses. Now look at the board. Isotopes. So if you consider isotope, all of you know hydrogen, that is normal hydrogen, then hydrogen 1 2, then hydrogen 1 3. It is called deuterium and it is called tritium or tritium. It is normal hydrogen. So Mendeleev arranged the element in increasing order of their atomic masses. So all of you know atomic masses of hydrogen is 1, helium is 2, suppose lithium 3, beryllium 4, boron 5, carbon 6, and so on. So see 1 2 3 4 5 6 and so on. But if we arrange the element in increasing order of their atomic masses, see hydrogen itself has 3 different masses, mass 1, mass 2, mass 3. So for hydrogen only we need 3 different positions. First hydrogen, so if we arrange according to Mendeleev law, so for hydrogen 1, hydrogen 2, hydrogen 3, again helium also 2. So try to understand, if you consider isotopes, so for one elements we need more than one position. So this is the first drawbacks or flaws of Mendeleev periodic table. So in Mendeleev periodic tables we cannot consider or we cannot give the position of the all isotopes. If you see the Mendeleev periodic table, there is only one hydrogen. But if you arrange according to the atomic masses, for hydrogen element particularly, we have 3 different masses. So since in Mendeleev periodic table we arrange the element increasing order of their atomic masses, so for one element we need 3 different positions. Understand? So if you consider the isotopes, so there is a drawback in the Mendeleev periodic table. We cannot place or give the position of hydrogens if you consider all the isotopes. Okay. So this is the first drawback. Okay. Second drawback of the Mendeleev periodic table is for rare earth metal. Rare earth metals. Okay. Now for some rare earth metal also we cannot give the proper position of the all rare earth metal, like isotope. For isotope we cannot give the position. For rare earth metals also we cannot give the proper position. Okay. Mainly these are the two drawbacks. Now, most important drawbacks is first isotopes. Hydrogen 1, hydrogen 2, hydrogen 3. Since hydrogen has 3 different masses, so we need 3 different positions, because Mendeleev arranged the element with increasing order of their atomic masses. Okay, now tell me, what is the atomic number of these hydrogen? 1, 1, 1. So now tell me, if we arrange the elements with respect to their atomic masses, for hydrogen, since 3 different masses are there, so we need 3 different positions. But if we consider this lower number means atomic number. All of you know upper number is atomic masses, lower number is atomic number. So if we arrange the element with respect to their atomic number, since the atomic number of the all isotopes are same, that is why if we arrange the element with respect to the atomic number, so for hydrogen we need only 1 position, because all of them have the same atomic number. 3 different positions are not required. Do you understand? Okay, so this is the main point. Scientists mostly give the same law like Mendeleev, but Mendeleev arranged the elements with respect to their atomic masses, but the modern periodic law is called Moseley's periodic law. Moseley arranged the element with respect to their atomic number. So Moseley easily solved the problem of this isotope. In Mendeleev law, for 1 element we need 3 positions, but in Moseley modern periodic law, since their atomic masses are same, so only 1 position is enough for 1 element. So problem solved. Now, later scientists, so we have first Döbereiner's triad law, second is Newlands Octaves law, third is Mendeleev main law, that is main periodic table. Later the word atomic masses changes to atomic number by Moseley. 4th law, and 5th law is there is no particular law, but 5th law is given by 5th law was given by Niels Bohr, scientist Bohr. Okay, scientist Bohr. It is called long periodic law. So Moseley law is modern periodic law. It is called Mendeleev periodic law related to atomic masses. Long modern periodic law related to atomic number, and long periodic law given by Bohr. So what is the long periodic table? Long periodic table, there are, okay, so tell me, what is this? Column or row? It is called column. Okay, so in long periodic law, that is Bohr's law, Niels Bohr's law, there are total 18 column. It is first, it is second, third, fourth, 5th up to 12, then 13, 14, 15, 16, 17, 18. So what is the total number of column? Total number of column is 18. 1 to 18. Okay. So up to down, it is called column. Okay. This first 2 is under S block. So keeping in your mind, in long periodic table we have total 4 blocks. Right now we discuss about the 3 blocks. First 2 column under S block, 3 to 12 under D block, and 13 to 18 under P block. And so S block, D block, P block, and F block written at lower position. So we don't discuss right now about F block, later we will discuss. So first 2 S block, then 3 to 12 D block, then 13 to 18 P block. Okay, and if we consider, so again up to down, total how many column? Total 18. This is also called group. So total how many groups are there in long periodic table? 18. So how many groups or how many columns? 18. Now as you move left to right, so left to right if you consider, then 1, 2, 3, 4, 5, 6, 7. So total 7 rows are there. Total number of row, horizontal row 7. So if you consider column, then 18. If you consider row, it is 7. Keeping in your mind, among these, shortest row is group 1 and longest is 6 and 7 both. Why 1 is shortest? Because when I'll discuss this concept of periodic table in next class, that is periodic property, you will see in 1, that is first period, contain only 2 elements, hydrogen and helium. Okay, so what is the shortest first and what is the longest? 6 and 7. In first, only 2 elements are there, hydrogen and helium. And in 6 and 7, how many elements? Keeping in your mind, 32 elements. So this is the basic concept related to all laws. We already completed all laws regarding to this first chapter. In next class, we will discuss the valency as well as all the properties related to radius, ionization energy and so on. So many properties are there. So first try to clear all the laws: Döbereiner's triad law, Newland octet law, Mendeleev periodic table, that is Mendeleev periodic law, Moseley, this modern law, and the long periodic table. There is no exactly law is there. Keeping in your mind this factual data: what is the total number of column and group? 18. What is the total number of rows? 7. Among these, which row is shortest? First row. And longest row is 6 and 7. It contains 32 elements and it contains 2 elements, hydrogen and helium. Okay, so this is our first class of this first chapter. Okay, so thank you, students.